Okay, welcome everybody. This is probably going to be a fairly short class. I only have a little bit of material on analysis of algorithms and complexity because I looked at it and decided there wasn't that much in addition to Monday that I wanted to add. There's a lot of stuff I do want to talk about, so we will get right into that. And then unfortunately, I'm theoretically in a 5 to 6 meeting for my other job. The woman who's hosting the meeting, who happens to sign the paychecks, is in Los Angeles, and that's only 2 o'clock her time. So we will get everything done that we can. All right. So apologies for just getting the slides out a few minutes ago. I think I posted them on GitHub like 2 or 3 minutes ago. There's not that many. As I said, I covered most of the stuff. I do want to talk about a couple of things. Then we're going to talk, I'm going to skip to talking just briefly about the final. Then we're going to talk about Project 3. And then when we satisfy that, we'll talk a little bit about complexity. And then we will talk about Lab 11 if you have any questions on that. So getting started. Student course evaluations. I know you've been here at UMBC for a number of semesters. You've done these for a lot of classes. I take sincere feedback very seriously, whether it be positive or negative. I just ask that it be constructive, make the course better for people who will take it in the future. If there's something you thought I did right, please tell me. If there's something you thought I did wrong, please also tell me. If you thought I was completely unfair and bombarded you with too many different tools with Slack and Discord and WebEx and Blackboard and Jupyter Notebooks and Anaconda and Pip and everything else, I mean, that's a fair comment. I'm looking for constructive things. This class sucked. While it may honestly be your opinion, is not going to be constructive for anybody. So please do the course evaluations. You should have received an invitation on Blackboard with a link to where to go do it. If you haven't gotten that, let me know. You have until which is next Tuesday, to do your evaluation. And again, I ask that you do it, and you just be constructive, positive or negative. I can take criticism. I'm a big boy. I've been around a long time. Anything that makes the class better for others is a good thing in my book. Lab 11, again, is due tomorrow night. We will talk about Lab 11 before we sign off this afternoon. We'll hopefully answer any questions you have or anything else. There will be a practice final later this week. Let me skip ahead to the last slide. It will be on Blackboard. I'll put a practice exam out by Friday night, okay, maybe Saturday morning. I intend to get it out by Friday night, but it will be on Blackboard. I understand you'll be working on Project 3, another assignment. If you don't have a chance to do it before next Monday, not a big deal. Next Monday's lecture will be going over the practice final and what to expect. In terms of what to expect next Friday night, the 15th, when we take the actual final, it'll be very similar to exam 2 in that it'll be all on Blackboard. You'll have the 2-hour period to do it. There will be 15 multiple choice or true and false questions. Those will be worth 4 points each, so that's 60% of the test. Instead of one debugging problem, there will be 2. They will be 10 points each, so that's a total of 20 points from debugging. There will be 8 short answer questions. Write a function, explain what this does, what happens here, things like that. You've seen those before. Those will each be worth 7 or 8 points, so that's going to be a total of 60 points for that section. And you will have 3 programming problems, 20 points each, for a total of 60. So that's where the 200 points from the final come from. So that's what you expect. It does not surprise me that many of you are far busier working on the project in the lab and worry about the final later. That's okay. We'll get there. So jumping back to this slide. What I want to do now is go over Project 3. Based on what I've seen on Slack, and I'm trying to respond to questions and give hints, I understand it's much harder when you can't sit with your laptop in front of me and show me exactly what's wrong. And so we're trying to figure out the context of errors. I know the TAs as well are trying. We'll get through it. Just please be patient. Explain as much you can about the error, and we'll get there. One thing a number of students have pointed out that I guess I prefer pip, the package installer for Python, to install everything. But a number of people have had a number of strange errors in trying to install Jupyter Notebooks with pip. If you prefer, you can use Anaconda to download them. And I guess this is particularly true with people who are on Windows. Macs, I haven't heard so much, but a lot of people are getting a lot of bizarre errors trying to install pip and run pip on Windows. So you have my full permission. There is no problem whatsoever with Project 3 about using Anaconda. Now, this is the web page you can go to. It's called anaconda.com individual. It's a free product. You can run it. Your data science toolkit, if you go here and click on download, it'll ask you what computer you have. It'll come down and say, hey, is this, Windows, Mac, Linux, Python 3.7, 64-bit, 32-bit. Do not download Python 2. Do not need it. We don't want it. It just causes problems. So pick the appropriate version for your computer if you're going to do Anaconda. And I know at least 2 or I think 3 students have had success installing Jupyter Notebook with Anaconda where they could not get it to work with pip. So if you're just banging your head against the wall figuratively trying to get it working with pip, go ahead and give Anaconda a shot. See if we can get it done that way. Okay. To make clear, make sure everybody's on the same page, make sure we're doing this right. You will be doing this project on your own computer. You will not be writing this on GL. You will not be using PyCharm. You don't have to. You will be using Jupyter Notebooks on your own computer, okay, to do this project. Submitting is now open. Let me give you the command line. When you are done, you will have a file named something, call it P Project 3, .ipynb, IPython notebook. So SCP that file, that .ipynb file to GL, to your account on GL, just SCP that file. That will put it on GL and it'll submit it that way. Submit CMSC. Let me avoid all confusion by making that a small s. Sometimes I hate Google Slides. CMSC 201, capital letters, Proj 3, and then, theoretically, Project 3.ipynb. So that's what you will do to submit Project 3. When you're done on your own computer, you'll have some file with a .ipynb, IPython notebook format. SCP that, just transfer that from your computer to GL, use the SCP program you've been using throughout this semester. And then when you're on GL, this is the submit command that you will use to submit that file for grading. That is how you will submit Project 3. Okay, that is open as of last night, so anybody who's going great guns and wants to submit, you can do it now. Again, there is no requirement that you submit a separate design document. Since I cut short the amount of time you had it by getting this out a few days late, we're not going to have that separate design document. But again, it should be fairly obvious you're following a design. Okay, now I want to walk through some of the things, go over a number of the problems I've seen on Slack. My view is if somebody has a problem, there's probably a few others who have the same one and just either haven't gotten there yet or haven't asked. When you start Jupyter Notebooks from your terminal, and so what I did, I'm on a Mac, so fairly simply, let me make sure I'm sharing my terminal. It would look very similar on a Windows box, except that it'll be a command prompt window. On a Mac, it's a terminal. And so what I did was I just got a command line and I said, Jupyter Notebook. I typed in that command, Jupyter Notebook. A bunch of stuff came through and it opened in a browser for me. Now, in my case, my default browser on my Mac, don't terminate this. That would be bad. My default browser on my Mac is Google Chrome. So if your default browser is Firefox or Safari or heaven help us all, Internet Explorer or whatever, it'll look slightly different because the browser's different, but this is the general idea. When you open Jupyter Notebooks, you will see something like this. What it does is it lists all the files on your computer that it can find that it thinks are Python files or existing Jupyter Notebook files. So that's what you'll see. You'll see a list of files it could find that it thinks are either Python or IPython notebooks that could be potential things you can open. Now, once you start your notebook, make sure you save it. Save it as an IPython notebook, and it'll pop up here, and you can click it. Now, I already have the file open, but I'm not going to go there right now. I'm going to try to walk you through a few things. So I'm going to start a new notebook. Okay. Now, the way I do that is I go over to this button labeled New. I click it. It gives me the option of what kind of file, what kind of notebook, because remember, Jupyter runs a bunch of different languages. I want a new Python 3 notebook, so I just click Python 3. Now I get a tab. Again, this is Chrome, so it may look different if you're in Firefox or something else. But in Chrome, this is what you will get. A brand new notebook that is untitled, that has one default cell, which is a code cell. Okay, a number of people have been having problems, and this was my live demo failure on Monday, reading in the file. One of the things you want to look at is what your working directory is right now, okay? So there are some Python extensions you can load, and you do that by just importing OS. Importing OS gives me some operating system level routines that I can work in. And anytime you want to execute, you just click that button that says run, and it executes the cell you're working in. Now, if I'm having trouble reading in the file, I want to check what my working directory is. I want to see where I am in the file system. What directory am I? Can I find this file? So the way I do that after having imported OS is by using a command !pwd. Now, pwd should look familiar to you. It's what you're using on GL. It is a Linux bash command that says literally print working directory. What directory am I in right now? Okay, and I click run, and it tells me I am actually in this Mac in my home directory, which is /user/Alfred Arsenal, right? That is my home directory on my Mac, and I rebooted it before class, so I would only load the stuff I need. And hopefully not have anything explode hilariously in the middle of this lecture. So I am in my home directory. Yeah, go right ahead.
So I did the import OS and typed the !pwd, and it gave me it's not recognized as internal or external command.
And you're in the middle of Jupyter Notebooks?
Yes.
That's interesting. Okay. Wow. Which one was not recognized, the !pwd or the import OS?
The pwd.
Okay. All right. I will make a note to look into that and get back to you as to why that didn't work, because I've actually tried this about a dozen times today and it always worked. So I'm going to have to look into that. All right. I'll make a note. Now, it so happens, and you can use Windows Explorer, or you can use, I'm sorry, you can use Windows Explorer if you're on Windows, or Finder if you're on a Mac. And I just happen to know where my data file is located. So I'm going to change directory so that my working directory is the place where my data file is located. And so I'm going to type OS. Let me look at the exact syntax. Sorry, I'm going to type it wrong. I'm going to cheat and go back to where I've done this already. Change dir. Okay, here we go. os.change dir, parentheses, in quotes, it's a string, it's a Python string, the directory I want to change to. In my case, on my Mac, it happens to be in a directory called pycharm/projects/code from Jan 29. And as to why that's the path, there's a long explanation I don't want to get into. I need to make sure I've got my upper and lower cases correctly. That looks to be it. Let's run that. Okay, and now exclamation pwd. Okay, and you see that I have changed directory. So as far as Garrett's question as to why exclamation point pwd was not found, I'm going to have to look into that. That's a strange one. That should be included when you imported OS. But this is one thing you can do. So now I know that my actual actual data is in this directory. So in terms of reading it, I should not have a problem. Okay, so now I need to import from plot9. I'm going, if I just do an import plot9, I'm going to have to use that in some of the commands later on. So from plot9, I'm just going to import some specific things I know I need. ggplot, aesthetic, which is AES, geom call, it helps if I spell it right, geom bar, cheat and look back. What else did I import? Just those. Okay. And I'm going to import pandas, because pandas is going to help me read in the data file. Run, make sure, what did I get him? Okay, what did I do wrong? From plot9, import ggplot, comma, geom underscore bar, okay. From plot9, I left out the import statement. Live demos. Bingo, now we work. Okay, now I want to read in my data file, and it's a CSV, and fortunately with pandas, I don't have to do the things I've been forcing you to do in projects 1 and 2 and read in the CSV file and handle it yourself. Pandas provides a way to read in an entire CSV file and put it into a frame completely by itself. So the way I'm going to do that right now is I'm going to say, I'm going to call my variable that I'm reading this in, data list equals. Now, if you, since I just imported pandas on its own, I have to give the statement pandas.read CSV. I'm in the proper directory, so I do not need to give a path name. I'm just going to give the data file name p3. p3 underscore data.csv. Okay. And then I'm going to want to print out the data. I'm just going to print it out. So we run this. Hey, it worked. This is what you should see. If you have successfully read in the data file, you can see that it automatically reads it in as a CSV. It labels these rows for you. Row 0 is US, row 1 is Spain. It put in, the first entry, the first row in my data file was the, country and then the date. So it automatically put on these column headings for me, and it gave me the row number and what have you. So this is what you should see if you have successfully read in the data file. If you have successfully read in the data file, you can see, and if you look at this slider bar and you follow it over, you'll see that we've now got all the data. Okay. So I ask you, once you've done that in project 3, what I want you to do is create a bar chart showing the number of COVID-19 cases, confirmed cases from that data file, which is from the Johns Hopkins website repository, in these countries on the last day, April 29th. Okay. So what do we want to do? We want to create a new object. This is where we have to look at the plot9 documentation. And somebody asked me, so I'll show all of you, make sure I get the right one. If you want documentation in detail on plot9, this is my go-to site. It's called plot9.readthedocs.io. And /n means this is the English version. There are a number of other languages as well. And /stable means it's not beta code, it's not test code. This is the version. So plot9.readthedocs.io /n/stable is my go-to for documentation. If you want to create bar charts, there's a section on examples and how they got them. It doesn't give you everything, but it gives you some examples and what you can do. There's some other stuff on there. That is a go-to for me. There are plenty of other sites with doc on plot9, but if you're having trouble, you're not sure the syntax of a command, then what you would do, you could go look at that for details. But at any rate, what's relevant is if you look at some of these, this is the command they use to generate the plot. It starts ggplot, parentheses, where I'm getting my data from, and that creates an object. That's the first part of it, that creates an object. So obviously I need something. Now I want to be able to store this. I want to be able to access this later on in the program. So I'm just going to call this a variable z. Z is going to be, I want a ggplot object, and I want it from the variable that I called data_list. I want it from this variable. So ggplot parentheses, data_list. That is going to give me a ggplot object. That's going to give me a graph, but I haven't said anything else about the graph. Okay. So I need something else to tell it I want a bar chart. Now this is kind of subtle and I needed to make my instructions clearer, which I will. But it turns out this works a whole lot better. You can create a bar chart with geom_bar, a geometry bar, or with geom_col. Make it look like columns. Okay, we're going to use geom_col because it turns out to look a lot better. If you use geom_bar, it gets really ugly really quick. We don't want to do that. Geom_, I'm missing a plus sign. The plus sign says this applies to my plot. Geom_col. Well, what do I want this thing to look like? Well, so I need an aesthetic, an AES, that says this is what this sucker is going to look like when I'm done. On my x-axis, that's going to be the country. And I need to match my upper and lower case. I need to match my spelling and everything else. So my x-axis is going to be the country. And my y-axis is going to be just the last day, 4/29/20. 2020. If I just before 29/20, it would fail. Okay, now we will see if this works or if I have to go back and figure out what exactly I missed in the syntax. But basically, to create a chart using plot9, create a new object from the data in data list, make it a bar chart. That's what geom_col does, makes it a bar chart. And aesthetically, I want the x-axis to be country, and I want the y-axis to be the date 4/29/2020. So it's only going to get that column to use as the data. Okay, that created it. Now I need to print it. And there is your bar chart, and it should look something like this. Now, hopefully you will play around with it and make it look nicer, but this is your basic bar chart. What it's done is on the x-axis of your plot, it's put the country, Brazil, China, France, Germany, Iran, Italy, Russia, Spain, Turkey. It's run the things together, United States and United Kingdom. It's given me on the y-axis 4/29/2020, that column, and then it's created automatically the scale in the bar chart, 250,000, 500,000, 750,000, a million. And this is kind of ugly, but you can see the US at this point has over 1 million cases, the UK a little under 250,000, and what have you. Now, suppose that I didn't want April 29th, 2020. Suppose that I wanted to look at April 1st, 2020. I'll just go back and change the date and rerun that, and now rerun this one, and now we see a completely different bar chart, right? The scale is different because nobody's above 1 million. The biggest at that point on April 1st was the US, had a little over 200,000. We can see that Italy looks a lot worse at 100,000, Spain, and what have you. So we can create these bar charts, and we can make them look pretty much any way you want. You can add color. You can make these by default, all the horizontal bars are the same width. They are scaled to fill the chart with small gaps between them. You can play around. You can make the bars different widths. You can fill them with different colors. You can put different colors on the numbers. You can do whatever you want. This is the basic. This is the minimum you have to do in the project, is create a bar chart like this. And as I told a couple of people, this project is deliberately designed so the actual Python coding is really not too hard. There's not a whole lot of significant Python coding. It's just playing around with the tools and getting the tools to work. I shouldn't say playing around. It's seriously learning to use the tools so you will have that skill in your pocket. And it's doing that, and the Python is kind of secondary except for a couple of things. But that is what you will do for this part of Project 3. Like I said, this stuff is really not necessary. This is just things I did to find out what directory I'm in. I will find out why PWD isn't working for Garrett or whoever else, but the rest of it is change directory working. Garrett, can you, if you import OS, can you then change directory and give it a path name inside single quotes, and will that work, or is that giving you an error as well?
What would I type to change directory? The os.chddir?
os.chddir, and then parentheses, and then it's a string, so you got to be inside quotes, and you can give it a path name, right? You can give it all the way from the C drive on down, or you can just change one directory or whatever.
Okay, let me try that.
Yeah, the point is I want to make sure if you accidentally type a directory that doesn't exist, that's fine. We can deal with that. I just want to make sure the actual command is working.
Yeah, that worked. I typed a path that doesn't exist, and the error was just they couldn't find the path specified.
That's fine, but that means the command works, which is good. I have to find out the PWD thing, but that's so. Like I said, this really is secondary to the actual project, but it's important because otherwise, it's not going to be able to find the data file, and you're going to get errors reading things in and out. So we will work and find out why that working directory is not working. But the other thing is you can move around in your file system and get to the data file, which is what we need. Okay. Now, where I'm going to have to put out supplemental documentation, I'll try to have it out by tomorrow at the latest. I want to give you more info in the last the last part of the project. Okay, the last part of the assignment, you have to create what we call a multi-line graph. Okay. That is, I want you to draw lines on a graph that show the path, that show the trend in the number of cases for each country, colored in a different color, so you can watch where the lines intersect and who's tailing off in cases and who's skyrocketing in cases and what have you. In order to do that, you actually have to transform the data, which is where the Python coding comes in, but I didn't give you a lot of instructions. So I will, if you get to the point where your bar chart's working and you're happy, just stop for a day and you'll have more instructions out tomorrow, or feel free to go on by yourself if you want to do it. But I need to give you some instructions on transforming the data so you can draw that multi-line plot, because Jupyter takes a specific format, or the multi-line plots just come out hideous. You'll get a plot that you'll never be able to read or understand. When we read in the data file, this chart right here, it looks like a 2D list, but internally is not technically a 2D list. Okay. It is a data frame. It's a special kind of thing that Pandas creates that we don't have to play with. We need to change that into a 2D list so that we can transform it. And so this will be the first step in the supplemental instruction sheet I'll get out hopefully sometime tomorrow. It will be on GitHub. I'll try to put it in Slack. We'll get it out there. When I type, let's call it a new variable. I'm just going to call it DL, short for data list, equals data list dot values dot to list, and make sure that works. Yep. And now I'm just going to print out DL. Okay. And now it's ugly to see, but if you look at it, you will see that what we have here is an honest by gosh 2D list. The left square bracket opens the outer list. The first row in our 2D list starts with this second square bracket, and in column 0 is US, in column 1 is 74. These are just the numbers for US. It comes down here. This right square bracket, that is row 1 in our 2D list, and then the comma separates list elements. So the left square bracket for Spain, this is now, or the US was row 0 in our 2D list. Spain is row 1, the second row in our 2D list. What we have done with this command is we have transformed the data frame into a 2D list, and you know how to program with 2D lists. You know how to manipulate, you know how you can do them. I will provide you the specific details. What you're going to do in order to produce the multi-line plot. Right now, if you look at the data frame, you have the headers and you have the dates 3/1/2020 and 3/2/2020 and so on. And then, the rows are labeled by country and what have you. In order to make the multi-line plot that you have to do in the last step of the project, you're going to have to transform that into US 3/1/2020 and then a number of cases. Then US 3/2/2020 and then the number of cases then. And then so on. Basically, you're going to have to transform the existing 2D list into a list that looks like this. So I will provide you detailed instructions on how to do that. And that's when I say I'm giving out supplemental instructions, that's what I'm going to do. I'm going to give out the specific instructions on how to transform this 2D list that I show in cell 13 on this document right now. The into a 2D list of the form you need, and then you can draw that multi-line plot. The multi-line plot will be very similar to how you drew the bar chart. There's just going to be a simple statement like this: create a new object with ggplot, and then it's not going to be geom_col, it's going to be geom_line, and then we'll tell you how to draw. So it's fairly straightforward, but you just do need have to transform the 2D list, but it's fairly easy. It's a couple of nested for loops. But I'll give that to you. That, I noticed there's a whole bunch of questions coming through on chat. I'm happy to answer them. Before we move on, because I want to make sure we get this. Like I said, I'll be available on Slack, and it's not due till midnight Monday. So we've got Monday's lecture before, but the faster we get this done, the more time you have to work on your other classes, and then we can sweat the final next week. Okay. I did see a question asking about Lab 11. The answer is it's due tomorrow night at midnight. So you have till tomorrow night at midnight to do Lab 11, and I will talk about that in a little bit. In answer to, I think it was Andrew said you use pip, should you use Conda? If you have Jupyter Networks working, stop. I mean, don't go back and look at Conda. Don't do anything else, right? If you have Jupyter Networks working, you're good. If you do not have Jupyter Notebook working correctly, if you can't get it, if you're getting permission denied errors, if you're getting you can't find it errors, if you can't get it to install with pip, then my recommendation is sure, take about half an hour or so and try to install it with Conda. Deep down, there should be no reason it works with one but not the other. But I know, as I said, there's at least two, and I think there's actually a third now of your classmates who were tearing their hair out trying to get it to work with pip and changed to doing it with Conda and got it working with Conda in a fairly short order. So by all means.
Quick question.
Yep, go ahead.
So I was able to successfully install it with pip, but I'm just not able to open it.
Okay. Are you another one having? Are you getting a permission denied error?
No. It just I just put Jupyter Notebook, and then it says Jupyter is not a recognized command because. Yeah, I don't know.
Okay, if that sounds like that's a path problem. But if you want to try it with Conda, it's not going to take you more than a half hour at the absolute most. And if it's going to save tearing your hair out, give it a shot. It can't hurt.
Yeah, it says there was a warning when I installed it that said consider adding this directory to path.
Andrew, my suggestion would be to find your actual Python, like I assume you're doing 3.8 scripts folder. Mine is in app data roaming under Python. Go to like cd that path all the way from c/users all the way to scripts. And then once you're in that path, type Jupyter Notebook.
Okay.
If
it worked for me when I did that.
Yeah, if you look at Slack, I think I said that in the project question thing. Yeah, in my case, on my Windows box, which I maintain so I can test all this stuff, in my Windows box, yeah, I need to C, use AL, app data, local programs, Python. My Python is 37-32/scripts. So, yeah,
Okay, I'll try that.
That's what I did in my Windows box. Okay. So yeah, if you try that real quick, that'll be faster than installing Conda.
Professor,
Yes.
all of that just kind of confused me. That was to do what?
Okay. If you have Jupyter Notebooks installed, but you can't open it because you're getting this is not a recognized command or directory, or can't find the path. Okay, what's probably happening, if that's the case, if Jupyter Notebooks is successfully installed, but you can't open it in the command line window, right? Then one thing to do is just, in the command line window, change directory to where your Python scripts are kept. And if you look in the Slack channel in the project questions group, I gave an example of where it is on mine. So like on mine, I can't do it because this is a Mac, not a Windows box. But for instance, on mine, in a command terminal on Windows, I put CD for change directory. In my case, it was C backslash users backslash al backslash app data backslash local backslash programs backslash Python. I'm running Python 3.7 on my Windows box, so the directory where Python is kept is called Python 37-32. If you're running 3.8, it'll be 38-32/scripts, right? And so I did a CD to change directory to that directory, right, in my Windows command. And once I did that, then yeah, that gives me a, I apologize, I missed who pointed it out. But if you do that, then that gives you direct access to Jupyter, to pip, to Conda, whatever, because this directory scripts is where those are actually going to be stored.
Also, pro tip on doing this, you guys, you don't have to type it out. You can like go to your file explorer where Python is installed, where the scripts directory is, and just copy that and paste it into the command line.
You are no fun at all.
I'm so sorry.
That's okay. I can't help it. I'm a geek. If you can't do it with a command line, you can't do it. Anyway, but you're right. But you're right. Yes, I understand very few people are have this strange habit like I do of typing in all these hideously long directory names. But yeah. Yeah, so the bottom line is in that scripts directory, like I said, if you're running Python 3.8, this 37-32 we'll say 38-32 or something. This just, I'm running Python 3.7.2 on that Windows box. Any rate, that's where the scripts will be found. And so that way, when you do that, and then you can type directly Jupyter Notebook, right? It shouldn't tell you it can't find it because it's in that directory. It's the whole notion of path problem solved. It's there. So that's what all that was about. Danielle, did that help you?
I just need yeah, I guess, but so you did it right when it pops up in your desk, like on another Explorer tab.
Yeah, when you see
Mac.
this in your browser tab,
Yeah.
right, that is exactly what you should see.
Okay.
So one more thing for people who might be having trouble. You can't close the command prompt window and still have your Jupyter Notebook working. The command prompt window runs Jupyter Notebook.
That is correct, and that's something I almost did. If I don't know how many people caught it, but like 2 minutes into this lecture, that's something I almost did. This is my terminal window on my Mac, where it's, like I said, in Windows it's command line, and on Mac it's a terminal window where I am running Jupyter Notebook. Okay, I almost decided to close this by clicking on the little red dot. And it asked me, do you really want to do this? Because guess what? If I had clicked on that to close it, it was going to wipe out my Jupyter Notebook session. And that would be bad because I haven't saved it. Okay. So the one other note, like I said, when you are ready to save, when you are ready to stop, like let's always save our work so we don't lose it in Jupyter. This is back to the notebook. This is the one I started this today in this class. And I've been working on. Let's save it. The way it's untitled right now, it does checkpoint, it's auto saved. I can recover. It's not hideous. But 32 minutes ago is a long time. That's a lot of work. I don't want to call it untitled. So I'm going to give it a new name, and it's going to be called Demo Project 3, right? And so now I go to File, and I click Save As. I can rename it. I can do whatever. I'm going to save as, and that gives me enter a notebook path relative to the notebook directory. I don't want it in any separate notebook path, but this is how you can save it in its own place on your laptop. I'm just going to say in the Proj 3 directory. I've got a couple of other things there. Okay. And it is now saved. And so the next time now I can actually terminate this. Now I can actually come back. I can reload this. And if I go down far enough in this list of files, which include notebooks that have been around for years, you will see that there is proj3.ipynb, project notebook. It was saved seconds ago. It's only 54 kilobytes and it's running. This other project 3 thing is my more detailed solution where I was fooling around with transforming that 2D list. So I didn't want to start over in that one. But once you save that file, right, once you save that notebook, here it is in Jupyter. Now I can quit. Now I can exit. I can even shut down this silly computer and I'm good, right? The next time I start Jupyter, I don't have to start new. I just go through this list and say, which one was it? And I find it, and if nothing else, I can get a hint, hey, the one from seconds ago, yeah, that's probably the one, or the one from yesterday, or whatever. So make sure you save your work. If you accidentally, as Kewantia said, don't close that terminal, but if you accidentally do, as long as everything's saved, it's not a big deal. You just restart and recover. Okay. Anything else on Project 3 for right now? Okay. Supplemental instructions on doing the data transform will be out tomorrow. It's due next Monday. If you're great guns and you finish it early, you can submit it now. You just submit the IPYND, the IPython notebook. Anna has a lot of experience with Jupyter notebooks. Jordan less so, but we're bringing Jordan up to speed real quick. She's great. Love Jordan. She's awesome. Awesome TA. Okay. That is Project 3. I do want to go immediately to a couple of notes on how do I install Plot9? Well, if you have either pip or conda, it's just a statement in the command terminal that says pip install Plot9 or conda install Plot9, and that should do it. Same thing with pandas if you need to install pandas. Okay. Let's see. I should look at the chat to see if I'm getting all the questions. Okay. How do you install Plot9 with Conda? We'll get to that. Okay. Okay. Alrighty. Is Project 3 the last project? You betcha. After Lab 11 tomorrow night and Project 3 due Monday, the only thing you have left is the final exam. Alrighty. Let's see. I think that covers everything. Lab 11. So most people seem to be doing sort of okay. People having problems writing some of the code. In this case, like I said, there's a file I gave you on my GL account in my pub directory. Nobody has indicated a problem fetching it, so I'm assuming you're all able to copy it. If you're having a problem, I gave you code. The first thing you should do when you set up your Lab 11 directory and you rename the file to Lab 11, then go ahead, use cat or Emacs if you prefer. Look at the code I gave you, make sure you understand it, run it. Go ahead and run it and see what, I ran it in class last time, but go ahead and run it yourself, see what you get, see how it works, see that it's different. In terms of the actual assignment, I gave you the code that counts the time. It sees how long in seconds it takes. Now, by default, my code generates a 10,000 element list of random integers between -100 and +100 inclusive, and then sorts that 10,000 element. I chose 10,000 because after playing around with it on GL, that's the one that took long enough for there to be a noticeable difference. I mean, when I started it with a 100 element list, everything was done in a small fraction of a second. And it was really hard to see, the quick sort was 1/10,000th of a second, while bubble sort was 1/100th of a second. Bluntly, who cares? If I will never notice 1/100th of a second. So 10,000 was big enough that it took some time to run. Bubble sorts 9, 10, 11, 12 seconds, depending on the randomness, how it works out. If you went to 100,000, it would probably take you, a couple of minutes to sort a couple of things. You might see more of a difference there. But like I said, by default, it's 10,000 and it's between -100 and +100 inclusive. So what I'm asking you to do in step 2 for bubble sort is just count the number of comparisons and swaps. Do that in the functions. Those are iterative functions. There should be no problem. It's straightforward. The actual number of comparisons and swaps you get, comparisons for both of them should be right around 50 million. You should get around 50 million comparisons. Just because 10,000 squared is 100 million, and if you do the math that it takes roughly n squared minus n quantity divided by 2, you should get right around 50 million comparisons for bubble sort and selection sort. The number of swaps you get for selection sort, there's some randomness, but the number of swaps you get for selection sort should be around 10,000. It may be less because sometimes by random chance, the element doesn't need to be swapped. It's already there. So you should get somewhere around 10,000, give or take. There's a little random, shouldn't be more, but there's a little randomness, it might be less. Bubble sort, the number of swaps is totally dependent on the random numbers generated. It will vary a lot from time to time. So anytime you run the program with a different random number, the number of swaps in bubble sort is just going to be a guess. Comparisons for both should be around 50 million, and swaps for selection sort should be a little under 10,000. Quick sort, because it's a recursive function, you can't just initialize. First of all, you don't do swaps, you do appends to lists, but you can't just initialize in one call and then close out at the end. What I tried to do in Quicksort is give you a hint. The basic code as written returns a sorted list. So the return of Quicksort is the list of integers sorted so far. And then you make recursive calls and you add lists together to append them. You also need to return, from each iteration, you need to return the number of comparisons and the number of appends. Or it's not swaps, it's appends, but you need to return that. So what you're going to have to do is construct a separate list. This is going to be a 2D list then. And so the way I did it, the way the instructions for Lab 11 say, is count the number of comparisons, the number of pens in the for loop. Then, when you call the function recursively, you need to keep track of them. So what you're going to do, you're going to return this outer list that has 3 elements. You still need to return the sorted list. Sorted list I put as the first element in the list of returns. The second element in the list of returns is how many comparisons I've done. And the third element in the list of returns is the number of appends I've done. So I'm actually returning, yes, it technically is a 2D list. Result in my instructions is a 2D list. The first element is that sorted list of numbers. The second element is the number of comparisons I've done so far. And the third element is the number of appends I've done so far. And then I accumulate them through recursive calls, and that's how I get my total number. And it should be, because quick sort on average is much, much faster than either bubble or selection sort. You should get much smaller numbers. I mean, you saw in the time variables that I gave you, that quick sort runs substantially faster, even on a list of 10,000. Quick sort should run in a small fraction, a few hundredths of a second maybe. Shouldn't even be a tenth of a second for quick sort to run. So you should also get a fairly small number of comparisons that appends a few thousand, maybe a couple of tens of thousands. Again, there's some randomness there. You won't get an exact number, but you should get somewhere in that ballpark. Step 3 then optimizes the code. You just keep track in bubble sort of whether you have swapped anything on the previous iteration or not. You go through an entire iteration of bubble sort without swapping 2 elements, then the list is sorted completely and totally, and you can stop. So I ask you in step 3 to write a new function, which takes bubble sort, optimizes it to just keep track of swaps, and stops if you're done, and then compare. Now, again, there's randomness. If you happen to generate randomly a 10,000 element list of numbers where there are still swaps all the way through to the 9,999th iteration through the list, right? Then optimize does not run any faster. You get the same results as regular bubble sort. There's some randomness here. There's a probability, if you know you from your math and probability classes, you can have some really bad luck. It'll happen. It's the old buying lottery ticket and matching none of the winning numbers. It's unlikely, but it can happen. Hopefully, though, you will randomly generate some numbers where optimize is about 2 times as fast as regular bubble sort. It should stop about halfway through. But again, there's some randomness. If you run it on 1 or 2 random lists and optimize is not much better, hey, you had bad luck in the random numbers. If you run it on 10 different random lists of numbers and you're still not getting better performance, double check your code. You should have at least some cases where you can stop early and optimize will be a lot better. Okay, so any questions on Lab 11? Again, you have till tomorrow night at midnight. It's open for submission. When you submit, remember, Lab is in all caps. It's submit CMSC 211. Submit, that's a lowercase. Google's going to uppercase it for me. It's lowercase. CMSC 201. Lab 11, all caps. And then you submit lab11.py, which is your code with the stuff added to it. That is your submit command. And again, I talked to the folks yesterday. It should be open now, and you have till midnight tomorrow. Okay. Any other questions on Lab 11?
Will the people in Discord for the office hours, will they be available for this?
They will be available, but that you might have to point them to where the assignment is. Unless you get Anna or Jordan. Anna or Jordan are familiar. The other TAs can do the Python programming. They'll be able to explain the idea because the major sections are covering exactly the same concepts. They're covering exactly the same thing. They just have a slightly different lab. So they are available. They can help you. You just might have to point them to the file that says, here is the assignment so they can understand what question.
Okay.
All right.
Thank you.
Okay. At this point, I apologize. The only thing I haven't covered in the slides, slides 3 and 4, just summarized last lectures, algorithm analysis. Big O. Big O is the worst case. We want to say, is this algorithm a good algorithm to use? I have an enormous number of things I have to sort, right? I did a project. The number of tweets globally every day is in the billions to trillions. Okay? We're not talking 10,000. We're not talking a million. We're talking thousands. So I did a project a few years ago when I was getting my master's in data science, right? If you want the list, if you want the complete set of all tweets that go out on Twitter every day, you can have it, but you have to pay. Not DMs, but tweets. You can get them all. You have to pay. You can get a sample of about 1/1,000,000th of them for free. Twitter calls it the garden hose. They call the full stream the fire hose. The small stream is called the garden hose. But even 1/1,000,000th of the tweets that go out worldwide every day is in the millions. So we were trying to sort tweets and we were trying to sort lists that were maybe 40 or 50 million elements long, or when we accumulated for 2 or 3 weeks, maybe 500 million elements long, we're trying to sort them. So the question is, should I use bubble sort to sort 500 million tweets? And the answer is by doing algorithm analysis, by looking at big O notation. Heck no. Do not use bubble sort to sort a 500 million long list of things. It will take forever. You'll be dead before it's done. Even using Amazon Web Services, the Amazon cloud, it'll take forever. We do algorithm analysis to tell us that in the worst case, big O notation, this is how long it's going to take, so you better be aware of it. It is sometimes useful to know the best case performance, and that's big omega notation. That's less useful because generally big omega means you have to get everything right. It's the first place you look. You bought the winning lotto ticket. Okay? But it's good to know that this is the best case. Now, if you have some algorithm that big O and big omega are the same, selection sort, big O is n squared, big omega is n squared for a list of n. That will tell you, that will give you something we call big theta. Okay? And theta is a good quantity to know about an algorithm because sometimes, quick sort big O, its worst possible case is also n squared. But most of the time, quick sort is n log n, which is a whole lot faster. So I'll go to quick sort. Right? But so quick sort does not have a big theta. Its best case and its worst case are different. A selection sort has a big theta. And in selection sort, big theta is n squared. And that tells me I'm never going to do worse, but I'm never, ever going to do better. So if I'm ever going to pick selection sort to solve a problem, it's going to be because I know that n squared is okay. Mostly n squared is not okay, and I'm not going to do that. So in terms of the final, we'll go over this next Monday. What I expect you to know on the final is that there's this thing called big O that tells you the worst case performance. There's this thing called big omega that it tells you the best case performance. And if big O and big omega are the same, then that's called big theta. And that's a good quantity to know because now we understand what this algorithm is going to cost us. Okay. If big O and big omega are different, then there is no big theta. Big theta is simply undefined. We cannot say what big theta is for quicksort. It doesn't exist. That's really all I want you to understand about analysis. It's the computer science topic of we have to decide what algorithm to apply to solve a problem. Here is how we analyze algorithms to come up with this. Here's this measure we have. And that is how we pick which algorithm to apply. Because there's a bunch of sorts. Okay. Anything else? Okay. I will be available on Slack, email. Slack is easier. DM me if you don't want. You can share it with the class. You can direct message me on Slack. If you don't want to share it with the class, that's fine too. I will be on every day. I will email as well. Sample exam will be out. I'm available for questions on lab until tomorrow night, on project until next Monday night. You'll still have Monday's lecture to ask about the project. It's not due till after then. If people are, I'd like to keep that deadline at Monday night for project 3, or if people are really, really, really having problems, we can talk about extensions on Monday, but please try to get it done before then because you got finals. Please do your student evaluation of the course and be constructive. If you think something stunk and I did horrible, tell me it was horrible, but be constructive about, do this better or whatever. Other than that, I apologize. I'm going to bail off 12 minutes early and I'm going to join my meeting with the people in Los Angeles. So thank you much, and I will talk to you later.